morning, students. Today we are going to see about mobile radio propagation. So in this we are going to see some of the topics like speed, wavelength and frequency, types of waves, radio frequency bands and propagation mechanisms, radio propagation effects and types of propagation, path loss, fading and the interference occurred during propagation. And speed, wavelength and frequency, you can see the AC current is 60 Hz and its wavelength is 5000 kilometers. FM radio is 100 megahertz of 3 meters. Cellular phone is 800 megahertz 37.5 centimeters and so on. And the types of waves we are classifying into ground wave, then space wave and sky wave. The signals are transmitted from the transmitter and it is received by the receiver, and through this ionosphere we have skywave propagation, space wave propagation, otherwise called as virtual propagation, so the straight line propagation, and also we depend on ground wave propagation which are very near to the ground. And here we are given radio frequency bands from the ELF to THF, and the frequency ranges are given, and we are having the low frequencies and very low frequency, and we are using for ground wave. And also the sky wave is high frequency, the space wave is very high frequency, ultra high and super high frequencies, and also the microwave propagation is taking place at this frequency range. And the propagation mechanisms are the three types: reflection, diffraction and scattering. Reflection is propagation waves impinging on an object which is larger as compared to the wavelength, and the diffraction is radio path between the transmitter and receiver obstructed by surface with sharp irregular edges, and also scattering objects smaller than the wavelength of the propagation waves. And this is the diagram which shows you the direct wave and also reflected wave and diffracted waves. And the free space propagation, the signals are transmitted from the antenna and is received by the receiver. As we are going to see, the receiver is available in the mobile vehicle, so we have the received signal power at the distance d is PR is equal to AR GT PT by 4 pi d squared. And the land propagation is, we have the ground wave propagation, the received signal is given by PR is equal to GR, GT and PT divided by L. So here we are coming across the fading, which is called as fast fading, slow fading and path loss. We have the propagation loss while the signal is transmitted to the receiver, so the loss is occurring in the channel. So here the antenna gain is, for a circular reflector antenna, the gain is G is equal to eta into pi d by lambda squared. And when you have a antenna with a diameter of 2 meters, the frequency of 6 gigahertz, the wavelength is 0.05, the gain is 39.4 dBs. Gain always calculated in dBs, that is called decibels. Higher the frequency, higher the gain for the same size antenna. The path loss is, we have LP is equal to PT by PR. Path loss in free space is L is equal to 32.45 with the 20 log to the base of FC plus 20 log to the base of D. FC is the carrier frequency, and this shows the greater than FC, more is the loss. And the path loss in the land frequency LP is equal to A into D lambda. A and lambda is the propagation constants. D is the distance between the transmitter and the receiver. Path loss is decreasing order. When it is in urban area, the loss is higher, and the urban area of medium and small cities is lesser, and suburban area is some more lesser, and open area there is very less path loss. And the fading is nothing but the reduction in the signal strength. We have fast fading and slow fading and path loss. So the slow fading is the long-term variation in the mean level is known as slow fading. This fading is caused by shading. So here we have calculating using the log normal distribution, that is PDF. And fast fading is the signal from the transmitter may be reflected from objects such as hills, buildings or vehicles, and here we are calculating is distribution by P of R is equal to R divided by tau squared. So here it is the calculated by the standard deviation. Fast fading again is calculated from the from the base station to the mobile host station is very far away. The envelope distribution received signal is Rician distribution. The PDF is given by r divided by tau squared into e power r squared plus alpha squared divided by d tau squared, where tau is the standard deviation. And the sum of the characteristics of standard amplitude is the level crossing rate and the fading rate, depth of fading and fading duration. Fading duration, time for which the signal is below the threshold. Depth of fading is the ratio of mean square value and the minimum value of the fading signal. Fading rate is number of signals envelope crosses the medium value in positive going direction per unit time. And we have the another some of the interferences that's causing while the signal is traveling through the channel, that is intersymbol interference. This is caused by the time delayed multipath signals and has the impact on burst error rate of signal. So it's mainly for the low bit rate error rate. So and we have the changes in the signals. While you are seeing this graph, you could understand the received signal, the propagation time received signal after a long delay. So and we have another interference called as Cochannel Interference. Channels having the same frequency interfere with each other. So here we have P C naught is equal to P of RD is greater than beta into RD. This is nothing but the co-channel probability. So these are the characteristics and also the interference occurring in the channel. So we have learned the characteristic and types of the propagations and the types of the waves which is propagating from the transmitter to the receiver, like propagation, skywave propagation, ground wave propagation and space wave propagation and its characteristic. Thank you. இது எங்க நிறுத்துறது தெரியலையே.